All right, today we're going to look at powers, and we're on page 7. And yesterday we looked at doing what? Translating what to what? Do you guys remember? Yes? Verbal expressions to that tough word. Yep, nonverbal, but specifically, Lucy? Algebraic expressions, okay? And you had to go back and forth. You're still going to do that tonight with your homework, but you're going to do it with powers now. So go ahead and start in your notes where you left off. And we're looking at powers. Do you guys remember what powers are? Can anyone tell me what a power is, or describe it at least? Matt, you want to try?
Like an exponent?
Yep, use of exponents. So I'm going to start off with an example here. I'm going to use 5 to the third power. There are parts to this expression right here. Now, technically, is this algebraic or numeric? What kind of expression is this right here? Jackson? Numeric, because it's only using numbers. Good. So this is a numeric expression. But what does this mean again? What's 5 to the third power mean in multiplication? Jack? 5 times 5 times 5. So it's repeated multiplication. Okay. So this expression right here is called a power. So I'll put it right here. It's called a power. So this whole thing right here, power, 5 to the third. And you also say 5 to the third power, but that's referring to everything right here. Okay, does anyone know what 5 is called? What is it called? And I'm looking at the bottom page 7, so if you're like, I have no clue, it's at the bottom, and there's some bold type terms on the bottom of page 7. Nate?
The base.
It's called the base. Okay, it's called the base. And what is this little number up here called, the 3 in this case? Yep. Exponent. All right, so you guys know the parts? Because, bless you, what's going to happen is they're going to say, all right, the base of this is raised to this exponent. You're like, base, exponent? You got to know base and then exponent. Or that evaluate the power. Like, the power? What's a power? That's what they're referring to, okay? So everyone okay with these introductory things? Okay, we're all good with that? Okay, I want you to be able to describe a power using multiplication and these words. So this is what I mean. 5 to the third power means that the base 5 is multiplied 3 times. Does that make sense? The base 5 is multiplied how many times? 3 times. Okay, so let's get another one here. Let's go 7 to the 4th power. Okay, what does that mean using multiplication? Try to use some of those terms that we just mentioned. So 7 to the 4th power, how would you state that using multiplication? Okay, Jack?
7 times 7.
So what did you do to figure that, like, what part got multiplied how many times? The base was multiplied 4 times, right? 7 times 7 times 7 times 7. Okay. Or used as a factor 4 times is technically the way you say it. Okay? What's the base here, Autumn, of this power? 7. What's the exponent, Lucy?
4.
Okay. What's the power up here that I just wrote down, Jenna?
The power is 7.
Good. 7 to 4. So you guys get that terminology? Get used to that. All right. We've been dealing with numerical expressions, but you can also use algebraic powers. Okay? So why is this called algebraic now? Just change to algebraic. Why? Brian?
Because there's a variable.
Yeah, it's a variable. Do I know what that number is? Nope. But is it a number? Yes. Okay. So how would I expand that using multiplication? Somebody? Yes.
You would do x.
All right, x times x times x. X is used as a factor 3 times. That's it. Sometimes you get this, and this is where it starts getting weird, and I'll get even more technical with you. So y to the nth power. Oh my goodness. Y to the nth power. Okay, if you know the terminology, that'll help you out. But what's the base in this power? y. What's the exponent of this power? Yep. N. Okay, do I know what n represents as a number? No, that's okay. But I do know that y is used as a factor how many times? N times. You're like, what? N times? You don't know what it is, but it does stand for a number. So I would read this y to the nth power. Sorry for all that. Y to the nth power, okay? This is what I talked to the last class about. This is actually kind of cool. Later on, you're going to be dealing with bases that have different types of numbers up here, like fractions and decimals. I know, right? That's not coming up yet. But what that means is this is used as a factor that many times. Half a time, 3.75 times. Okay, that gets technical, but you'll be able to handle it as we get to it. It's going to change the way you work it out, but it's not going to change the way, the basic process. Okay? So don't be afraid. All right, bottom of page 7. Do you guys see that little chart at the bottom? It has one column that says symbols, words, and then meaning. You guys there? Okay, Harrison, what's the first symbol? On the bottom of page 7, in that box, the first symbol is 5. Okay, it tells you how to read it. 5 to the first power. Okay, when you have an exponent of 1, first power. Okay, the next one, 5 with a 2 exponent. So how would you read that? Clear?
5 to the second power.
5 to the second power? What's another way to read that? And this is something you have to get comfortable with.
5 squared.
5 squared, okay? So when you have an exponent of 2, you can say that base to the second power or that base squared. Did you guys get that? I don't like using the word squared. That's okay, but you got to get comfortable with it. All right, what if you have an exponent of 3? 2 ways to read it. In this case, 5 to the, or 5. Lily?
5 to the third power or 5 cubed.
5 to the third power or 5 cubed. Okay? What about exponent of 4? 5 to the fourth power, I get that. 5 quadrid, quartile. There's no special name for that. For 2 and 3 only are there special names. Okay, so how would you say 5 with the exponent of 4? The only way to say it really is anybody or everybody. 5 with an exponent of 4, you would say 5 to the fourth power. What about exponent of 5? So 5 to the fifth power. Okay? And then you see the last expression, x to the nth power. Okay, do you know how many times x is used as a factor? But how many times is it used algebraically? N times. Okay, get used to that. Terminology is weird, but at least you know how to say it. Okay, like I said before, you're going to be able to go from the algebraic to the verbal and verbal to the algebraic. You got to be able to go back and forth. But let's go ahead and turn the page to page 8, and let's look at a couple examples. Okay, who can read me example 3, the bold type? So the instructions in example 3. Okay, Claire?
Write a power that represents the number of small squares in the large square.
Okay, so if you're in the top of page 8, you guys see a little grid there? Okay, do you guys see that there's a large square in that problem, but there are also smaller squares that make up that large square? Okay, how would you use powers to describe how many small squares there are in the large square? So how would you go about doing that? So this is example 3. All right. Anybody? How in the world would you use powers? So base and an exponent? Really? Okay. Do you notice anything about that square? Yeah? Sorry? Okay, so the word square refers to like squared, that there's a relationship there. What squared would make up how many little squares there are there? So how many little squares are there? Anybody? Anyone count them all up? 1, 2, 3. 64. Is there any way to write that using powers or using a base and exponent? Yep.
Well, 8 times 8 equals 64, so 8 squared.
Yeah, what did you guys figure it out by doing 8 times 8? Why would you do 8 times 8? Because what would you do? You would multiply by the, remember geometry a little bit? Yes ma'am? Length times the width. And what do you know about the length and the width? And that square, they are the exact same thing. So 8 times 8 is 8 squared. So what does 8 times 8 equal? 64. Okay, I'm going to get into a little side discussion, but I think this is going to be beneficial. All right. Is there any other way to come up with 64 using a base and a power and an exponent? So can you use another base and another exponent to come up with 64? Actually, there are many ways, but another way, yeah?
It would be 4.
4 to what power?
4.
Okay,
8.
a little lower. You start with 4, go lower.
2.
Go higher.
4. 3.
Go lower.
3.
4 to the third power. Okay, ready guys? Mental math. What's 4 times 4? 16. What's 16 times 4? Oh, that also equals 64. Okay, there's another one using a base of,
16.
not 16, because if you did like 16 to the second, that'd be 16 times 16. 2 to what exponent?
4.
So 2 times, oh, you want to guess?
6.
To the 6. Okay, let's try it out. So I'm going to pull up how many times I use 2. All right, 2 times 2 times 2 times 2 times 2 times 2. So 2 to the 6th is also equal to 64. The one we wanted to get was this one, by the way, but I'm trying to show you something here. Okay, this is where it gets, oh man, this gets so cool when you get into it, but it's going to be hard if I try to make you do it now, but try to follow me here. Okay, do you notice, bless you, is this making you, are you allergic to this? No. 8 to the second power gets me 64. 4 to the third power gets me 64. 2 to the sixth power gets me 64. Are there any other numbers that can be raised to another number that get me 64? And the answer is yes. Do you know how many there are? Infinite. Okay, you can actually use a fraction to some power to get me 64. Your base will be a fraction. Your exponent might be a fraction too. You can do that. It's totally allowed. Remember how I said you were going to use decimals and fractions here? Yeah, you're going to get to that and you're going to be able to get to 64. So that's dealing with logarithms, and that's one of the scariest words in Algebra 1 and 2. Logarithm. Can you say that with me? Logarithm. Okay? It's scary, but that just means exponent. This is a nice fancy way. Okay, side note there. All right, any questions on example 3 dealing with the square? You guys get that? By the way, do you know how we got the word squared? So think of this example. We use 8 to the second power. When you're talking about 8 to the second power, geometrically, you're thinking of what shape? A square. So 8 squared refers to a square. So why do you think we use cubed? Three-dimensional, referring to a cube that has the same length, width, and height. So length, width, height. Okay, example 4. Read that for me. Somebody. Evaluate 3 to the 4th power. Okay, what's the base here, Rosalind?
3.
What's the exponent, Carson? 4. What's the power, Harrison?
3.
So that's the base?
4.
It'd be 3 to the 4th. That's all of it. That's the power. That's okay. Don't worry. I'll give you another chance later. What does that mean using multiplication? How do you expand it using multiplication? It means, yeah? 3 times 3 times 3 times 3. So 3 is used as a factor how many times? 4 times. Okay, here's how you figure out the value of 3 to the 4th power. All right, normally 3 times 3, what is that going to get you? 9. And then you can go 9 times 3, and then times 3 again, and you'll get your answer. But what's another way to do it? Yeah?
3 times 3.
Oh, do these first? Okay, what do you get? 9 times 9? What's that? Okay, ready? What's 3 times 3? 9. What's 9 times 3? 27. What's 27 times 3? Has to be 81, right? So you can do it that way, or you can do it this way. Just make sure that you know. You can change the order of the factors and still get the same product. Excuse me. Wow. Same product. So 81 is the value of 3 to the 4th power. You guys get that? You guys good on it? Questions on this? Okay. Stop recording.